What's up mga bubuyog, at nagbabalik naman tayo sa ating topic tungkol sa stresses in beams, but this time ang pag-uusapan naman natin ay tungkol sa shear stress. Let's go! So, di ba kung naalala nyo sa ating mga previous videos na pag-usapan natin doon yung tungkol sa flexure or bending stress, and nasabi natin na it is caused by a bending moment.
So it also means that a shearing force can cause a stress, which we will discuss today, known as the shear stress. Alright?
Okay, to exemplify it further, tignan natin itong ating beam, no? So, itong ating beam is made out of thin layers. So, thin plates yan, no? Hindi yan solid na iisa. So, pinagpatong-patong lang yan. Okay, so pag maglalagay tayo dito ng load, no? Sabihin natin na dito sa sentro, so hindi siya unli. Ayun, kapag naglagay tayo dyan, may possibility na itong ating mga thin plates is mag-slip sila, no? Mag-slip sila tapos maghiwa-hiwalay, mag-disintegrate. Now, imagine natin ano yung mangyayari kapag solid na block na yan. Now, kapag ganyan na yung beam natin, mga bis, di ba mas mahirap? Mas mahirap silang mag-slip or hindi na sila mag-slip. Now, saan papasok dito yung concept ng shear stress? Ang shear stress ang responsible para hindi sila mag-slip with one another, para hindi sila maghiwalay, kagaya nito. Para hindi sila maghiwalay, shear stress ang responsible. Therefore, masasabi natin na mas malaki yung capacity ng shear stress dito sa ating solid block as compared dito sa ating thin layers. Kasi kapag nasa thin layers lang yan, di ba? Mababa yung shear stress capacity as compared kapag solid block na yan. Okay, ngayon, siguro tatanong nyo, di ba yung the shear force acts vertically on our beam? So, bakit siya, we are doing it horizontally? Ang explanation dyan, mga bisto, nabasa ko rin lang sa libro, no? Share ko lang. A shear stress is always accompanied by a complementary shear stress of equal magnitude. The two stresses acting on mutually perpendicular planes. Ayun, di ko rin gets eh. Pero, yung nag-gets ko dyan, kapag meron daw nag-a-act na shear stress dito sa ating plane, meron daw yung complementary shear stress din sa perpendicular part niya. So, since perpendicular sa horizontal, yung pag-ganun. So, this is the resultant shear stress caused by the vertical shear force. Okay? Ngayon, how will we solve for the value of our shear stress? So, what is our formula? Okay, so breakdown natin yung ating formula. This letter T or the Greek letter tau, this is the shearing stress, yung sinusolve natin. And then we have V or the shear. So, this V most of the time is the maximum shear, okay? Doesn't matter kung positive shear ba yan or negative shear. It doesn't matter kapag symmetrical yung cross-section mo or unsymmetrical. We always get the maximum shear. Pero it depends naman, no? Pero it depends naman if ano yung sinusolve sa problem. Baka sinabi lang na find the shearing stress at this section. Of course, you are not sure that the shear force at this section is equal to the maximum shear. So, you just get what is the value of V here. Pero if you are finding for the maximum shear stress, of course, this value of V should be the maximum shear force. And that will reflect on your shear diagram. Okay? Next, itong Q, this is the moment of area. And I think this is also called the first area moment. I'm not sure. But I think so. Yun yung naalala ko. Tapos, meron tayong I or the centroidal moment of inertia. Na-solve din natin to sa ating flexural stress, and then B, which is the width of the cut section. So, para makuha tong tatlo, ang pinakaunang kailangan natin gawin is to find for the neutral axis. Kapag symmetrical yung section natin, mga bis, no? If that's symmetrical, we already know that the neutral axis lies on the center. Dito yan mismo, okay? Dito yan mismo. Implied na yan, mga bis, no, na dito yung ating neutral axis. So, kapag symmetrical, medyo mapapadali yung paghihirap natin. Madali ba yung paghihirap? Kaya nga paghihirap eh, kasi hindi madali. Okay, pero kapag unsymmetrical, mga bis, no, let's say mga ganyan, let's say T-beam yung mga ganyan, we need to solve first for the neutral axis. And how will we do that? We just need to solve for this bar Y, no? And we solve the formula of summation of AY over summation of area. Ayun, review na lang to sa ating statics. Now, pagkatapos nating makuha yung location ng ating neutral axis, we can now start solving for I or the centroidal moment of inertia. Kapag symmetrical yan, madali lang makuha yung moment of inertia niyan, mga bis, no? We just need to use the basic formulas for moment of inertia, yung mga base height cube over 12 and so on and so forth. Pero kapag unsymmetrical yan, mga bis, no? we need to use the parallel axis theorem or transfer distance. Next, Q or the moment of area. Let's say we have here a rectangular cross-section and this is the neutral axis. So to solve for Q with reference to the neutral axis, mga bis, no, we just need to get the area of this. Ito yung area niyan. Let's say yan is 2 and this is 2. So that's 2 times 2. And we just need to multiply the location of the centroid of that certain figure to the neutral axis or to the reference point that we set. So that's times 1. So magiging 4 yung ating Q. Now, you can choose if you want to solve the Q above or below. It will always give you the same answer. Okay? So, how if yung tinatanong naman is ano yung value ng Q at this reference line? Okay? So, same lang din mga bis. You need to choose kung ano yung solve nyo. It's either yung taas or baba. Parehas rin lang mga bis. It will give you the same answer. So, if I choose the top portion, no, parehas rin na yung process. I will get the area of this and that's 2. Let's say this is 1. So, 2 times 1 is 2 times 1. Tapos, yung ano yung location ng centroid ng ating figure na to, yung ito lang, papunta sa ating neutral axis. So, since that's rectangles, this is 0.5. Tapos, yung natira dito na 1, edi from neutral axis to that centroid is times 1.5. So, that's the value of your Q. The same din kapag gusto mo na yung buong ito yung kunin mo. Magbibigay din yan ng same answer. Let's say this whole, yung bottom portion naman, yan. Let's say this is 2 times 3. So, Q is equal to 2 times 3 times, ano yung distance nito papunta sa ating neutral axis? Let's say 0.5. It will still give you the same answer. So, you can choose if it's up or bottom. Alright? So, that's how to solve for our Q or the moment of area. And then, lastly is this B or the cut section. Okay, so this B, mga bis, no? Kapag ito yung ating, let's say this is the cross section of our beam and yung pinili nating reference point is ito. Ang value ng B would be this length plus this length kung saan mo pinutol. Okay, so kapag circle yan, yon, dito yung B na yan. Kapag let's say I-beam, yan. Kapag pinutol mo yan dito, dito yan. Kapag pinutol mo yan dito, sa taas na yan. Okay? So, depende. Nagva-vary itong Q and yung B natin kung saan natin gustong hanapin yung value ng shear stress. Okay? Kasi mga bis, no, kunwari, ito yung ating cross-section. Okay? Kunwari, ito yung cross-section natin, mga bis. Okay, yung shear stress kasi natin from the bottom, papuntang taas, mga bis, is nagva-vary. And how will we solve for the shear stress at this point? Shear stress at that point, shear stress at that point, magva-vary tayo dyan sa ating Q and B. Itong V and I, constant yan all throughout. So, kung gusto nating makuha itong portion dito, mapapalitan yung Q and B. Kapag dito rin, mapapalitan yung Q and B. Okay? So, ito yung dalawa, ito yung binabago natin para mahanap kung ano yung mga shear stress at different locations sa ating cross-section. Okay? Now, let's discuss the location of the maximum shear stress. Kasi usually, yan naman talaga yung pinapahanap, di ba? Let's say if we have here a beam, let's say ito yung kaniyang shear diagram, and the location of the maximum shear stress will always lie on the maximum shear. So ito, the value of, let's say that's X, no, or let's say that's P. This value P will be your maximum shear. So dito sa section na to, dito ka mag-start ng analysis mo kung gusto mong mahanap yung maximum shear. It doesn't matter kapag positive or negative. You always choose the absolute maximum, okay? So this V will be your maximum shear force, okay? To find for the T max or the maximum shearing stress. So this V should also be your max, okay? V max. Now, so dito sa section na to, let's say ang cross section yan is T-beam. Diba sabi natin kanina, yung pinakaunang gagawin natin ay para hanapin yung location ng neutral axis. And since unsymmetrical siya, kailangan natin gumamit ng formula na summation of AY over summation of A. Okay? So, kapag nahanap na natin yung neutral axis, let's say, ito, andito yung location ng ating neutral axis, then we can now finally solve for I using, of course, the parallel axis theorem or transfer distance. Now, itong V and I, they are constant, okay? So, hindi yan magpapalit. Ngayon, along this cross-section, mga bis, nagva-vary kasi yung value ng ating shear. So, yung value ng shear dito ay magkaiba dito, magkaiba dito, magkaiba dito, dyan, and so on and so forth. So, meron tayong tinatawag na shear stress distribution. Sometimes it will look something like that or something like that. Depende yung itsura ng ating shear stress distribution. Itong ating shear stress distribution, this will show kung ano yung mga values ng ating shear at various parts ng ating cross-section. So, sa level na to, magkakaiba yung value ng ating shear stress. Okay, so yung tanong ngayon, asan dito yung location ng maximum shear stress? Usually, no, ang ating neutral axis is usually most of the time the location of the maximum shear stress. But it's not all the time, okay? It's just a candidate kung saan pwede nating mahanap yung location ng ating shear stress. So, always find first kung ano yung shear stress dito sa ating neutral axis, okay? Now, ano yung mga instances na hindi sa neutral axis yung location ng ating maximum shear stress? Okay, take a look at this formula. Itong V, mga bis, no? Constant yan. Hindi yan magpapalit kahit palipat-lipat ka ng reference line. Itong I, constant din yan kahit magpalipat-lipat ka ng reference line. However, this Q and this B varies along this cross-section. So, kung dito yung ginawa mong reference line, mag-iiba yan. Kapag dito, mag-iiba. Diba? So, this Q and B are the varying factor. Now, this Q is maximum at the neutral axis. Q max, the maximum value of Q will always lie at the neutral axis. Q max is always at the neutral axis. Kaya palaging candidate ito, yung ating neutral axis for the location of the maximum shear stress. Kasi nga, mga bis, diba? Tignan mo, directly proportional sila. Habang lumalaki yung Q, lumalaki yung ating shear stress. However, itong B, diba? Kung makikita natin, itong B, kapag bumababa yung B, no? Lumalaki din yung value ng Tmax, right? They are inversely proportional. That is why, kapag yung neutral axis nyo, for example, dito, no? For example, ganito. Kapag yung neutral axis nyo is andito, for example, dito siya sa taas. Okay, kapag dito yung neutral axis nyo, kung makikita nyo, pwede nyo pang mapababa yung value ng B. You can solve it also here, right? Kasi kapag mas mababa yung value ng B, mas tataas yung Tmax as compared dito. Now, para ma-compare mo yung dalawang sagot, you will need to solve for the shear stress at the neutral axis and also solve at the shear stress at this point and then compare which one is maximum, okay? Pero kapag yung neutral axis mo naman is at this point, kung makikita mo, this is the least cut section, right? Mas maliit to kaysa dito, then okay ka na. You can conclude that the maximum shear stress lies at this point, okay? Okay, so in conclusion, unang gagawin natin is hanapin natin yung ating shear stress at the neutral axis, okay? So, always yon, palaging hanapin natin sa neutral axis. Now, if i-compare nyo, tignan nyo, sa cross-section nyo ba, yung location ba ng neutral axis yung pinakamaliit, yung B? Kapag yes, you are sure that the maximum shear lies on the neutral axis. Pero kapag yung sagot nyo is no, katulad ng part na to, na yung neutral axis nyo is hindi yung pinakamaliit na section, which is ito, you are required to solve some more parts. Kailangan mong isolve yung mga mas maliit pa para mag-compare ka kung saan doon yung mas maximum, yung mas malaki, okay? And as a tip, magandang i-consider nyo yung mga points of connections, yung mga junctions nila dito. Mostly, kapag andito yung neutral axis nyo, mostly andito yung concentration ng shear. Dito yung maximum niya, okay? So, I hope malinaw yon kahit magulo. Okay, so let's get started. Let's go. Okay, so ito yung ating problem, mga bis. So ito yung ating simply supported B. Meron siyang distributed load. Solve na rin yung reaction. So, yan, thank you kasi hindi na tayo mas mahihirapan. And nakalagay na rin yung ating shear diagram. So, bawas problema yan, mga bis. So ito yung ating cross-section. So, 3 kahoy daw yan na pinagdikit-dikit ng glue. So, Elmer's wood glue. May wood glue ba yung Elmer's? Check nyo na lang. Comment down below kung meron. Ayun. Tapos, yung pinapasolve niya, mga bis, ay ano daw yung maximum shear stress sa glue? Kapag sa glue yung tinatanong, yung maximum shear stress sa glue is of course dito. Right? Dito sa portion. Dito yung tinatanong niya kasi dito yung location ng glue eh. Dito lang naman yan dinikit. Right? And then, sa maximum shear stress sa wood. Yung location ng maximum shear stress ng wood is, I'm sure, nandito sa neutral axis. Bakit, mga bis? First, di ba? Ito yung nagbabari kasi natin. Sabi natin, Q is largest at the neutral axis, right? Q max at neutral axis. And itong B natin, mga bis, itong B natin, hindi na yan nagbabago all throughout our cross-section kasi symmetrical sila eh. So, we are sure that the maximum shear stress in the wood lies upon this neutral axis. Pero yung ating glue, yung shear stress sa glue is dito lang sa point na to. Okay? So, we need to solve the value of shear at this point and at this point. This is for the glue and this is for the wood. Right? Check natin yung ating formula. Doon natin simulan yung analysis. Tau is equals to VQ over IB. Alright? So, ano yung meron na tayo? V, alam na natin yung V, right? Kasi V max yung hinahanap natin kasi we are finding for the max shear stress. So, V should also be maximum. And looking at our shear diagram, our maximum shear are located in our supports with a value of 24 kilonewtons. So, ox na tayo dyan. Next, itong ating I. Itong ating I, mga bis, di pa natin alam yan. Pero pwede natin yung mas-solve, right? Using the base times height cube over 3 kasi rectangle lang naman, right? Next, the value of our Q, of course, we have 2Q. First, the Q at the wood and the Q at the glue. And then B, our B is okay na rin kasi alam natin na yung cut section na to ay 160 mm. So, okay. So, simulan natin muna sa glue. Okay. So, punta muna tayo sa ating glue. So, sa ating glue, the tau at the glue is equal to V. Ang value ng ating V ay 24 kilonewtons. Okay. Times yung ating Q. So, how will we solve for the value of Q at the glue? Q at the glue. Okay, so Q at the glue, mga bis, is equal sa yung area sa either above or below ng glue. So, di ba ito yung glue natin? Yan. So, we select kung ano yung gusto nating i-analyze, yung taas ba na to or yung baba. So, kahit saan dyan, pwedeng-pwede. So, I will select yung taas kasi mas madali, di ba? So, ito, ano yung area niyan? That's 80 times 160. 80 times 160 times yung location ng centroid na to papunta sa ating neutral axis, this height. So what is the length of that height? We know that this is 80 mm, therefore the centroid is from there to there is that's 40, right? Oo, 40 kasi half lang eh. Tapos mula neutral axis papunta dito sa glue is another 40. Therefore, from the neutral axis dito, papunta sa centroid na to, that's 40 plus 40, that's 80 mm. So, we multiply here, 80. Okay, so that's the value of our Q. So, multiply natin yan. 160 times 80 times 80, that's 1,024,024. 1,024,123. And unit, it's mm. So, mm cube. Okay. So, dito, alam na natin yung value ng ating Q, right? Q is 1024,123 mm cube divided by ano yung ating I? Yung ating I, di natin alam yan. Pero pwede natin yung isolve, right? I is equals to base times height cube over 12. Base is 160. Height is yung buong ito. 80 times 3 is 24, I think 240. Pero naka-cube yan. Divided by 12. Therefore, I is equal to 184,320,123 mm raised to 4. So, yan. Sulat natin dito. 184,320,123 tapos mm raised to 4. And then, multiplied to B. What's the value of B again? B is the distance of this cut section. Since nasa glue tayo, parehas din naman, this section is 160 mm. Okay, before natin to calculator mga bis, gusto kong i-convert itong kilonewton sa newton. Bakit? Kasi yung gusto kong sagot ay newton per millimeter squared, which is megapascal. Okay? So, to do that, we will just multiply here 1,000, right? Kasi 1 kilonewton is 1,000 newtons, right? So, calculator na lang natin to. Our answer is 0.8333 megapascal. Okay, so MPa. Next, punta naman tayo dito sa ating 2 or the maximum shear stress at the wood. So, tau wood. Okay. Now, same formula. VQ over IB pa rin. So, V is still the max shear stress or shear force, I should say, which is 24 kilonewtons. So, that's 24 times. Ang value ng ating Q ay magbabago ngayon. Kasi ang Q na to, that's Q glue, right? It's reference at this point kung saan yung glue portion. Pero, yung hinahanap kasi natin, the maximum shear stress, sabi nga natin, occurs at the neutral axis. Right? Okay, so solve natin yung value ng Q natin dito. Q would. Okay, so piliin natin kung sa taas ba or sa baba. Pero same lang naman yan. So, okay lang sa taas. So, we solve for the area. That's 80. Tapos yung natira dito ay 40. Yes. So, 80 plus 40 is 120. Times yung width, which is 160. Multiplied sa location of the neutral axis. Dito, papunta sa ating centroid. That's equal to 120 divided by 2 is 60. Yeah. So, times 60. Therefore, the value of our Q would be equal to 12 times, 120 times 160 times 60. That's 11,520. 11,520, 1, 2, 3. Okay, so, yun yung value natin dito. 11,520, 1, 2, 3. 0, 0, 0 pala. Okay. Divided by yung value ng ating I, that's uniform along the cross-section or along this section. Hindi yan magbabago. Okay? So, that's 184, 320, 1, 2, 3 times. That's B or the width of the cut section. Same lang length, 160. And don't forget to multiply 1,000. Okay, so makita nyo mga bis, no? The value of Q here, dito sa wood, dito mga bis, so the value of Q right here at the neutral axis, dito, is far way larger as compared dito sa portion ng glue, which is 102400, diba? 1152, ito 1024. So that proves that the value of Q is maximum is at the neutral axis. Okay, so palaging candidate itong neutral axis sa location ng maximum shear stress. So pag sinolve na natin to, that would be equal to 0.9375 megapascal. Okay, so if we try to compare both, mas malaki yung shear stress dito sa neutral axis. The maximum shear stress of the whole section occurs at the neutral axis. This value and that value. So ayun mga bis, no? Here's the answer. So wait. 8. Parehas lang. Kasi this is in megapascal and this is in kilopascal. Minove lang 3 decimal places. So, ayun mga bis, no? Marami pa tayong mga example wherein mas magigets natin kung paano yung concept talaga, paano yung process sa pag-solve ng ating shear stress. So, that's it mga bis. Maraming salamat kung nag-stay ka dito hanggang sa dulo. Please like, share, and subscribe. Muli ako po yung bubuyog na nagpapalala sa inyo. Maglaro manaliksik, maging matinik. Jabi out.